All right, welcome back to our video series on how to build an L1 rocket. Today we'll be going over laser cutting the fin assembly. So just to preface this is a video meant to give an idea of what happens in this step. It is not as thorough of a video as the previous three. So as a reminder, the previous three videos and presentations were on designing your open rocket, modeling the fin assembly, making your nose cone. Now we're going to laser cut the fin assembly. So this again assumes that you have done these previous three steps, or at least the first two steps. So a little note on what laser cutting is. It's essentially a way of cutting 2D shapes in 3 dimensions out of thin sheets of material. The general materials used are wood, plastic, sometimes fiberboard, other types of thin, easily cuttable things. Certain laser cutters can even cut metal, but we don't really do that here. This is perfectly suited for our design, which is made of flat panels that are extruded into the 3rd dimension. It's really easy for the laser cutter to sort of follow those lines, and as you can see here in the picture on the right, cut out more complicated shapes out of thin pieces of wood. So we'll be cutting out our fins out of thin wood today, or at least going over the general strategy for how that happens. And the input for these laser cutting machines is usually an Adobe Illustrator file that when you set the line width, thickness, and color to a certain set of settings, the laser cutter then knows how powerful to make the laser at that certain point, and it'll cut the part out for you. Now, there are 2 places we can laser cut our parts. The highly recommended one is in the Nolop Makerspace, which if you're unfamiliar with, it's just behind Kindleven. So if you go to the Kindleven Cafe and you keep walking past the stairs that would bring you up into the SEC lobby and then turn left, you'll enter the Nolop Makerspace. So they have 2 laser cutters. They have a 12-inch by 24-inch beds. Sometimes there's a line, but there's always people there who are able to help you use them. It's a fantastic resource. They're best suited for 3mm parts, and there's a bunch of info on this web page here if you guys want to check it out. Now, the alternative option is to go across the street to Bray Labs. They have a larger bed, so that means they can cut larger parts if you have, for some reason, really big fins. They can cut thicker parts with more ease, but it's also more complicated to use and a little bit logistically more challenging just to get over there and to find the thicker wood and all that. So a quick note on part thickness. If you'll remember from our open rocket slides and video, that generally the fins and the centering rings were 3mm, although you had the option to make 6mm fins, and that the top and bottom rings were both 6mm thick. So the Nolop Makerspace laser cutters work best with 3mm parts. They'll be faster, they'll have much cleaner cuts, and at the time of writing and the time of filming, the Nolop employees are asking that you don't cut 6mm wood. That may change on short notice. It has changed in the past. But regardless, it's highly recommended to cut everything out of 3mm wood. Now, for the 6mm thick parts, you can go over to Bray and cut those out of 6mm thick wood, or you can just stack 2 parts together. Because of the geometry of these parts, so I'll go over to the assembly here. Just because these rings here are held in place on the top and bottom by the fins and the vertical supports, making these out of 2 is not exactly a problem. And again, the loads on these parts are going to be going up, and same thing here, they'll be going up. So there's going to be no shear forces that would require a sort of a solid part there. If you do want to cut out 6mm parts, please use the Bray Labs laser cutter. It will work so much better. I have cut several sets of 6mm fins, and I have cut some in Nolop and I've cut some in Bray, and it works so much better in Bray, so much cleaner, so much faster. The risk of setting the laser cutter on fire is a lot lower. I have also done that. Do not recommend. But again, situation may change, so this is something you should definitely check with the L1 lead before you laser cut your parts. Make sure you are all set and on track and not missing anything major. Again, I'd just like to emphasize that the Nolop employees are super helpful, very friendly. they'll always be there to sort of help you guys laser cut your parts. So if for some reason the L1 lead isn't there to help you out with that, there's always someone there who's laser cut something before and who is happy to assist you. So the general process for laser cutting is going to be, we'll export our designs from 3 dimensions back into 2 dimensions. We'll go to the Nolop Makerspace itself, where you'll go because I'm not going anywhere since I'm filming this video. They'll import your DXF designs into an Adobe Illustrator file and arrange everything on a single sheet, or if you really can't fit it on a single sheet, onto 2 sheets. This is just to save material and to cut as many parts out in one go as you can. Then you'll tune and set the line color and width so that the laser cutter knows which parts to actually cut. If you forget this type, your laser cutter might not actually cut anything or might only do shallow cuts. It's important to get that right. And then you need to prepare the laser cutter, calibrate it, load your wood, and get ready to cut your parts. So it's relatively straightforward, although it seems a little scary at first. So step 1, export your CAD files as DXFs. This is quite straightforward, honestly. I'll run through it really quickly. So if you go back over to Onshape, we'll go to the example fin here. I'll click on the top surface of the part. So this is the part I want in my DXF. This is the part that has the shape of the entire fin. And what the laser cutter will do is it'll just go trace these outside lines here with the laser firing down at the part, and that'll just burn a cut through around the shape of the part. And then I'll get a fin. So I right click on this, export as DXF DWG. I'll just rename that like that. I want a DXF. I want this version here. By the time you're watching this, there might be new versions. I don't know. I always use release 14. It works great. We want to download that, and we want to set the Z height to 0 and normals to positive just to make sure our DXF works well. So we'll export that, and that's essentially the entire process. We'll repeat the same process for our other things, making sure we get the top face. Again, export, download, and make sure you export a DXF for your top ring, your thrust plate, and for your centering rings. Now, as a reminder, in the assembly, we have 4 fins, and if you have, depending on how big your motor is, you might have multiple centering rings. Like I do here, I have 3 centering rings. You only need to download 1 DXF for each type of part, because then in the Adobe Illustrator software, you can always copy paste it. That does seem simple. I don't think I realized that way back when I was just starting to learn this, but it helps streamline the process quite a bit. The next step, so the next 2 steps in this process, I'm just going to give a quick, rough overview. I'd like to emphasize this part up here, that there are more detailed instructions available in Nolop. So they have this printed out and laminated little series of pages that they leave on the table next to the laser cutters. Those have really detailed instructions on how to go from DXFs to Adobe Illustrator files and then to fully cut and finished parts. So if you're unfamiliar with the laser cutters, or it's your first time, or even if it's your first few times, please refer to those or that booklet there for the most detailed way on how to do everything. They have lots of pictures, lots of screenshots. It's kind of more towards the level of detail in the past 2 or 3 presentations that I've made. It's very useful, highly recommend. But the general strategy is that you'll open Adobe Illustrator, you'll select a 12 by 24 inch template if you're in Nolop, which matches the bed size of the Nolop laser cutter. You'll import each DXF into an Illustrator file. Huge note here to be sure to convert the units. When you click to import your part, it'll ask you what the import units are. If you change one of those units, it'll change the conversion to be, say, if you change from inches to millimeters, it'll change from 1 to 25.4. Make sure you change that back to 1, so it always imports it at a 1-to-1 scale in the units you asked for. Then, once you have your parts in Adobe Illustrator files, you can copy paste them into a single sheet and sort of outline it to fit as many parts as you can onto a single sheet. And make sure to set the line color to pure RGB red, the stroke width to 0.001 inches. And then you're ready to go, essentially. There's, again, a lot more detail in the instructions next to the Nolop laser cutter, but this is kind of to give you an idea of how the process will work. And finally, setting up the laser cutter itself. So I'll admit this would be a lot more helpful if I was physically in Nolop filming this. But again, this is a rough outline. Please follow the Nolop laser cutter instructions and ask anyone in the Nolop Makerspace for help. If not, the L1 lead is always happy to help out with laser cutting. So the material we'll be using is birch. This is the 3mm plywood that's available in Nolop at the Nolop store. We have a tab set up for SEDS where you can go and sort of write your name and the cost of the material you've purchased, and we'll pay for it directly, so you don't need to pay anything. Then in the laser cutter itself, once you've sent from this previous step, once you've sent your file to the quote unquote printer, it opens another set of software that you can use to check that everything is set up properly in the laser cutter. You'll need to load your wood, you'll need to calibrate the laser essentially so that it doesn't burn too big of a line through the wood, but so that it still burns all the way through the wood. You need to make sure that you set your wood thickness properly. I usually use 3.7 mm, but the best practice is to measure your wood and then add maybe 0.2 to 0.5 mm on top of that. And then a very important step is to check that your cuts will not go off of the wood or off of the build plate. Build plate, by using the pointer and clicker in the 3D printing, in the laser cutting setup software to move the laser cutter head around and sort of see where the laser will cut. And then if you do all that properly, once you close the lid and hit start, it should cut all the way through and cut all of your parts out. It's very important to watch your cut the entire time. Sometimes little flames will pop up and that's normal, but if your cut starts really catching on fire, it's important to be there to pay attention to it and to be able to ask for help if you need it. Again, as someone who has set the laser cutter on fire, it's important to be there and watch it and be careful. Now, some quick troubleshooting things. Again, Nolop employees will be there to help you if any of these issues come up. But from my own recommendations and our own experience building L1s and cutting out L1 parts, if your parts do not cut all the way through the first time, increase the power or reduce the speed. What also works well is if they're only very marginally attached. Use an X-Acto knife to cut out your parts, but make sure you flip the wood over onto the table first so that you're cutting out from the back side, so not from the side that was cut by the laser. If you can see the lines on the back side there, then that should be enough sort of pre-cut for you to be able to cut through with an X-Acto knife. If you turn the wood over and you can't see any burn marks at all, that generally means that if you try and cut it out with an X-Acto knife, it'll cut out very poorly. And I would not recommend using a knife then. I just recommend restarting everything and recutting, basically with higher power. Now, if you've popped out your parts, you've X-Acto knifed them out or just picked them out and assembled them together and they don't fit. If they're too tight, definitely check your dimensions in the CAD. There's a chance you made a small mistake there. Happens all the time, it's really easy. And then you can fix and widen your slots as needed in the CAD, re-export the DXFs and recut everything. Or you can just take a file or some sandpaper and file things down until everything fits. This part's a little bit more tedious, but if you don't feel like adjusting things or don't feel like recutting, you can definitely go with that. And finally, if your parts fit together too loosely, this is quite an easy problem to have, especially if the laser cutter burned through too much of the wood. So if it was poorly focused, if it was too powerful, if it was moving too slowly, it could take off too much of the wood around the edge of the part. And then the tolerances might have been thrown off a little bit. And then the parts won't fit together, won't hold together as well, and can fall out of alignment a little bit once you're epoxying them together. So it would be important to refocus the laser. Again, ask an Nolop employee for help. Double check your dimensions. Make sure that your slot widths and heights are properly set and not for some reason absurdly loose. And then reduce the laser speed and or power just a little bit. Let me actually correct this. It should be increase laser speed and or reduce power. I'll correct that in the presentation. And that's about it for this quick little video. Hopefully this gives a good overview on what the laser cutting manufacturing process looks like. My hope is that eventually in the future, there'll be more information added to this, showing exactly how it's done. But for now, Please use the Nolop resources. Please use the knowledge of the L1 lead and other more experienced members of the club. And best of luck.